Hello everyone, we are now going to begin our lecture on variations of the median. So far we studied the variations of the mean, the different variations that we learned about the mean were the range, the variance and the standard deviation, correct? Now those measures of variations apply only to the mean. You cannot apply these to the median. Median has its own set of variations, and that's what we are going to learn in this section of the chapter. The variations related to the median are quartiles, interquartile range, upper limit and lower limit. These are some classifications around the quartiles. And then we'll talk about the 5-number summary and then a graphical representation of the variations, which is called box plots. Now, the first measure that we are going to learn about is called quartiles. The quartiles define the spread of a data set by dividing the data into 4 equal parts as much as the median divides it into 2 equal parts. So the word quartile suggests quarters, correct? And quarters means 4. So we have the data divided into 4 parts here. Just like the median, when we were talking about the median, if you recall, we first had to order our list from the lowest value to the highest value, and then the median was located smack at the center, at the midpoint of the data set. So the median value was supposed to be found right at the center of an ordered list, and 50% of the observations would be to the left of the median, and 50% would be to the right above the median value. Right now, with quartiles, we divide the data set into 4 equal parts. So here we had 50% and 50% for the median. For quartiles, we'll have 25%, 25, 25, and 25. So the first 25% will be to the left of what we call quartile 1. Then the second 25% will be between Q1 and Q2, quartile 1 and quartile 2. Then another 25% between Q2 and Q3, and the final 25% will come to the right of Q3, above values above the quartile 3 mark. All right, and we can have different distribution shapes. As we had learned before, there can be uniform distribution, that means same number of values in each quartile, or we can have a bell-shaped symmetric distribution, but we'll still have 25% observations in each quartile. And then there'll be we can have a right skewed distribution as well as a left skewed distribution is also an option. So there are essentially 3 quartiles that divide the data into 4 parts. So we are going to learn how to find these 3 quartiles, and the process is pretty much the same as finding the median. All right. So let's find out how to locate the quartiles and pick the values of the quartiles. Now, again, as I said before, the process is going to be the same as finding the median. Only thing is we have to have several iterations of finding the median, all right, for different sections of the data set. So first, arrange the data in increasing order. Just like when you find your median, you have to order your data in ascending order from lowest to highest. And then determine the median. So first step is to find the median. So if you know how to find the median, you should be able to find the second quartile of the data set, right? So did we first find the median, and then once we find the median, so let me show you here. All right, we have ordered our data set from lowest to highest. The first step is to find the median, which will be right in the center, and that median value is going to be called Q2. All right, so we will start by finding the quartile, second quartile, quartile 2, which is the same as median. All right, it is the median. Quartile 2 is the median. All right, so when we just have the median defined, we will have 50% of the data to the left and 50% of observations to the right. Now we have to find the other two quartiles. To find quartile 1, what we do is we divide the ordered data set into two halves. So this is one half here. The left side is one half, 50%, and the right side is the other half that we have. Okay, a bottom half and a top half. So we'll just call it the left half and the right half. All right, and if the number of observations is odd, include the median in both halves. And so if n is an odd value, then we will include the median in both halves. If n is an even value, then you can leave out the median. We will work through an example of this. All right, so don't worry, but let me just try to explain the process at this time. So the first quartile, let me take out my pointer here. The first quartile, Q1, is the median of the bottom half of the data set. All right, the bottom half meaning they refer to the lower half, values that come uh, below the median. All right, values that are less than the median. So we take the data set from the first to up to the point of the median, correct? And then we find so now our data set is divided into two parts from here to this point, all right? And we find the median of just this set of data on the left hand side. So we are going to find the median of the lower half of the data. And the median should be located right at the center of this first half of the data, and we will call that Q1. Again, the process of finding Q1 is the same as finding the median. The only thing is you are working with just half of your data set on the left hand side. For Q3, you do the same thing but to the other half of your data set. So this time our data is going to be start from the right hand side all the way to the end of the list, and we find the median right at the center of the upper half of the data set. So Q3 is going to be the median of the upper half. Okay, so that's how we are going to find our three quartiles. So each time we are dividing the data into two and then finding the median. We are following the process of finding the median. And for the lower half, we call that Q1. For the upper half, we call the Q3. And for Q2, it is the median value of the full range of data set. Now this particular slide just formalizes the procedure. It's essentially the same thing that we just discussed in the previous slide. So I'm just going to skip over it, but you can pause this on this slide and read it yourself if you want. But says the very same thing that we discussed in the previous slide. Now, after we find our quartiles, we can take some measurements, simple measurements on the quartiles, right? Or from the quartiles, really. The first of that is the interquartile range. The interquartile range is nothing but the difference between the first and the third quartile. So the formula for it is Q3, that means quartile 3 minus quartile 1. So essentially, if we have our quartiles here as Q1 and Q2 and Q3, what the IQR gives is the distance between the quartile 3 and the quartile 1 value. All right, so that represents our IQR, interquartile range. Now, once we have identified our quartile values, so quartile 1, quartile 2, and quartile 3, we can combine them with the lowest and the highest values in the data set and come up with what's called the 5-number summary. So 5-number summary of a data set is the minimum value in the data set, the value of quartile 1, quartile 2, quartile 3, and then finally the maximum value, the highest value in the data set. Now, once we have the interquartile range calculated, we can use that value to find out what the lower limit of the data set would be and what the upper limit of the data set would be. The formula for the lower limit is Q1, that means quartile 1, minus 1.5. Now 1.5 is a constant value, it won't change, all right? So 1.5 multiplied by the interquartile range IQR value that we calculated before. And I'm going to surround this with brackets just to indicate that this part, the multiplication, has to be completed before we subtract the result from quartile 1. So as you can tell, the lower limit is going to be a value to the left of quartile 1. It's better be less than quartile 1. Upper limit, on the other hand, goes with this formula, quartile 3 plus 1.5 times IQR, and let's surround this with brackets too, because we first have to complete the multiplication of 1.5 times IQR and then we add it to quartile 3. And that tells us that the upper limit value will be positioned to the right of quartile 3. Okay, it's going to be a value greater than quartile 3 because we are adding an amount to quartile 3. All right, so let's say we have our data set here with the minimum value here, the maximum value on the extreme right side, and then we have our quartiles, quartile 1, quartile 2, and quartile 3. Now, what the lower limit and the upper limit help us with is to identify any potential outliers. To identify potential outliers in the data set. That means values that probably doesn't belong in the data set, right? They are extreme values. So once we have calculated our lower limit. Now let's say its position, the lower limit is somewhere over here. All right, let's say this is the lower limit of the data set and the upper limit, let's say, is out here. Upper limit is a value right here beyond the maximum value. And we need to identify the outliers, if there are any potential outliers. All right, what we do is we take our lower limit value and see if there are any values less than the lower limit. All right, take your lower limit and check if there are any values in the data set that's less than the lower limit. Here the minimum value looks like is less than the lower limit. So any values that are less than the lower limit would be considered or would be regarded as potential outliers. So let me write that again. Any value or values less than the lower limit would be regarded as potential outliers. Outliers. If there are any values greater than the upper limit, all right, any values greater than the upper limit that we find using this formula here would be potential outliers. Potential outliers. So if your lower limit and upper limit values fall outside the minimum and maximum value range, like in this case, the upper limit is outside the highest value in the data set, that means there are no potential outliers, right? So we will again go through a worksheet in which we will do all these calculations starting from finding the quartiles. So just wait a little until that one is available. But first go through the concepts behind the variations of the median. A box plot is a graphical representation of the variations of the median. The way we go about constructing a box plot is to first determine the quartile. So we must first calculate or find what our quartile values are: quartile 1, quartile 2, quartile 3. You can have the 5-number summary. The 5-number summary includes the minimum value and the maximum value as well, correct? And then in step 2, we need to determine potential outliers and the adjacent values. So it's possible there wouldn't be any potential outliers, but you have to check that by first finding out what the IQR is. In order to identify potential outliers, you have to calculate the IQR, which is Q3 minus Q1. And once we have our IQR, we can use the formulas for lower limit and upper limit and come up with those values of lower limit and upper limits. And once we have all this information, we can identify our potential outliers, right? If there are any. So we have our potential outliers and the adjacent values completed in step 2. In step 3, it says draw a horizontal line on which the numbers obtained in steps 1 and 2 can be located. Above this axis, mark the quartiles and the adjacent values with vertical lines. So the way we go about is we have our horizontal line. So draw a horizontal line and there identify your quartile 1 values, and please write the quartile 1 value and then quartile 2 value and then perhaps quartile 3 value. All right. And then what you do is just put a dot here over each quartile. All right. Above the horizontal line. It should not be, your dots should not be on the horizontal line. It should be above the horizontal line. And the adjacent values, which could be potential outliers, can be placed to the left or to the right. All right. But what we should do once we have our quartiles plotted, just draw a straight line and then like this, right? And make a box, all right, a rectangular box, and lines running vertically through the dots above the horizontal line. Right, so here we have indicated our quartiles and then adjacent values. Now, if there are no potential outliers, just identify the minimum and the maximum values. All right, and connect them. It's also called the box and whisker plot. All right, so connect them with a straight line. So here it says connect the quartiles to make a box. So we did make a box and then connect the box to the adjacent values with lines. So we connected them with lines. All right. And if there are any potential outliers, you may just want to mark them with an asterisk. All right, somewhere here, if there is another one outside the maximum value. All right. Now, sometimes they ask us to, or you will see that in some cases, instead of connecting with the minimum and the maximum value, they connect with the lower limit and the upper limit, especially if there are any asterisks involved. All right. So uh, you can also, if you mark or connect the whiskers with the lower limit and upper limit, that's fine too as well. Now here are three pictures of different types of box plots. The first one here is a right skewed curve, right? It's a right skewed curve. It has a long tail to the right and it peaks towards the left. And this would happen when quartile 1 and quartile 2 are close to each other and quartile 3 is somewhat distant from quartile 1 and quartile 2. Well, really quartile 2. In a symmetric distribution, quartile 1, quartile 2, and quartile 3 would be equally spaced. And for a left skewed distribution, quartile 1 would be a little further to the left from quartile 2 than quartile 3 is. So there's more space. There's more space between quartile 1 and quartile 2 than there is between quartile 2 and quartile 3. That makes it a left skewed distribution, right?